DSA is not hard. You just have to learn data structure in a right way. For example, walking is very normal for you. It is not hard. You don't have to stress your mind because it is actually in real life it is very normal. Same way, for you to make data structures very normal, very easy, very relaxed, you have to relate it with the real life examples. Let's see in this video top 10 data structures with their real life applications. Let's start.
Good visuals, good life is all that matters. Health that you got right there is all that matters.
But before moving, let's see what a data structure is. A data structure basically is a way to organize and store the data. Data structure. And basically it's a systematic and efficient manner. And the most important part is it plays a very critical role in building efficient systems. Now number one, we have the list, also known as the linked list. Now you might have heard about singly and doubly linked list. So basically a list basically are the nodes which are connected to each other one after the another. And if something is connected backwards also, then it is also called as a doubly linked list. What's the benefit of it? You can actually remove a node in between and then connect to other nodes very easily. So it is used for storing and manipulating an ordered data when the data is ordered one after the another. For example, in your to-do list, you can see that you have the entire list of what you have to do. Basically, you have stored and organized your task in a form of a list. The same way we saw that we can add, remove or reorder this one element of the list, same way we can order this specific element or this specific element from this list. Again, we can add multiple extra operations, for example, marking it as complete or not, all that stuff. Not only this, but also your feed, which is generated real time on your Twitter, Instagram, Facebook, is also based on this list, ordered list, which help you to view the latest content as the most recent, most up content which comes in is the most latest, most recent content. Not only this, but also your shopping carts are also stored in a form of a list one after the another. Your music player, when you play your music, you can go and forward the music, you can go and check the back music. This is also a doubly linked list. Thus, in all these places, you can actually see that your list is being used. Next data structure we have is the arrays. Basically, it is suitable where the size does not change frequently. For example, you have seen whenever you go on and book a movie ticket, you book a specific seat. That specific seat is actually a array, a 2D array in which one place, one cell you are actually booking. But if you said that cinema seat at row 5 and column 2, please book that. Mark that true or false. Not only this, arrays have a very wide applications. For example, storing large data sets. In machine learning models, you have to store the data in the form of tables. That is a 2D array itself. And it helps us to find the average of specific data, to find the max and min of that data, to actually calculate the trends on that data. This is actually helpful and 2D array helps us in that. Not only this, but also in image processing. You know that every image is a collection of pixels and every pixel is nothing but an array. So I can represent the image in the form of a 2D array. Again, if you add colors and stuff, you can actually make it a 3D array also, but this is how image manipulation and image transformation are actually worked on most efficiently. Next comes is our stack, last in first out, more specifically used for your undo and redo operations. Specifically, you have seen in your text editors, your VS Code, your Sublime editor, in which you write something and then you have to do Control Z. It is actually very easy. How that Control Z works is because of stack. How? Let's say if I write Aryan, so Aryan have gone to stack. I write is has also gone to stack. I write mad. So now the statement is Aryan is mad. It has gone into stack in that order itself. But now I do a Control Z. I know, okay, no, Aryan is not mad. Aryan is smart. So I have to do a Control Z, or basically you can do a delete operation also. But yeah, I do Control Z. So I actually remove the mad. So this mad will actually go out from the top of the stack, and then I can write a smart. So it becomes Aryan is smart. The same way it is also used in your browser history. So basically anytime, right now also you can go and long press on your this browser back button, and then you will see a stack of all searches you have done in that order itself. This was the first search, then next search, then next search, and the next search, and this is the most recent search which I have done. So your browser history is also based on that of the stack. After stack, his brother comes in, which is nothing but a queue. You have seen many people saying standing in a queue, standing in a line. That is nothing but a queue itself. As you have seen in many shops, many first release stores, that a queue is actually made in which the first person stands at the first top of the line of the queue, the last person stands it. Any new incoming person will stand after the last person, and the first person will be the person to go inside this door. So we can easily say that the first in, first out, the person who came in first will actually go out of the line first. And that is how queue also works. Now the most real life application for it is the printer job. You must have had used a printer in your life. In that you put on multiple papers. So all the papers go inside in the printer in the form of a queue, and the paper which went in first will be the paper that will be processed first, as in printed first. Not only this, but also in your WhatsApp, you must have seen that always, even if you write the chat, even if your network is not working, still the messages will be delivered in a sequential order. How is that happening? Because your messages are shown in form of a queue. Every message you type, it is displayed in the correct sequence because it knows that you entered a message, it has to go and deliver that message in the correct order. So it's also used in your chat messages. Now next comes is our heap, also known as the priority queue. Now why is that priority queue named? Because it gives the priority to some specific kind of element. Specifically, you have a min heap which gives priority to the minimum element, and thus you can extract out the minimum element in the most efficient time. Thus it is named as the priority queue. Some real life use cases which you must have seen is the task scheduler. Minimum resources jobs are completed first and parallelly based on how much resources they are taking. They can't be pending for other jobs which will for sure take more resources. And next is the memory management. You must have heard about out of memory error, heap spaces full. All this comes because your heap memory is actually the memory which is full. As you can see, you have heard of terms malloc, kelloc, all that is actually a heap memory. So thus it's very importantly used in your memory allocation, memory management also. Next is our trees. Organize data hierarchically, which simply means that represent your data with actual hierarchy or relationships. You must have heard about the family tree diagram in your childhood. You must have been taught this diagram. This is nothing but a hierarchy or a basic relationship which we discussed to represent the family. The same way this tree is used in database indexing, specifically to speed up the insert, to speed up the search, and to speed up the delete operations. And specifically, you must have heard of the term B and B plus tree. These are commonly used in the relational databases, specifically index and speed up the large amount of data operations. Not only database indexing, but also your AI decision making is based on this tree. You must have heard about the decision tree diagram, or basically decision tree classifier. It actually used for machine learning classification to classify something as a cat or a dog. Must have heard about this, right? That is based on the decision tree diagram. And also your entire file system is actually a tree structure. Now next is our hash tables, specifically used for data lookup, which means searching, for insertion of data, and also for deletion of data, which has the most efficient time, which is just over one operation. How it does is it actually uses a hash function to map a key to corresponding value, and this is the correct bucket location which it maps to because of the hash function. For example, it is used in actually your search engines. For example, I wrote a term Aryan graph playlist, then you should be getting the proper search results. So what he would do internally is he would have mapped Aryan to all the possible related links which could have been linked to the term Aryan. Then he will go and search for the graph and search for all the graph related data. Then he will search for the playlist and search for all the playlist related data, and then mixing, matching all these, he will give you the best possible outcome. Thus here every word is a key and corresponding links or attributes or files is their values. Not only this, but also you must have seen that you whenever open something again and again, it actually opens very fast. It is because of the caching. Caching is nothing but storing something which is rapidly or frequently used, and you actually store that in memory. That is simply done by using your hash tables. So So for example, 3 people are accessing specific thing from this device, but let's say these 2 have accessed it before, so they can access directly from the cache. They don't have to directly go and query that, which can take a long time. Cache will return information like this. And this hash table is also used in your interpreters or compilers to actually transform or interpret the data. Now next is your tries or suffix tree. It is specifically used for searching strings in your documents. Now whenever strings for documents comes in picture, for short documents you will see in text editors, and strings specifically are seen in your search algorithms. A try as a word also is similar to a tree data structure, is also from a tree. But actually every node is actually a character of a string, and it is very highly used in your search algorithms. Whenever you write any word and you have not completed the word, it shows you a large number of recommendations. These recommendations are actually based on your try data structure, and thus searching for this string in a large corpus of data becomes very efficient because of this try data structure. Now one of the most favorite of programmers is DP. The main task of dynamic programming is to remember what has already happened before. For example, a very famous 0-1 knapsack problem, which says that you have some weight of items and you have some value of those corresponding items, and I have given you a knapsack, and I have given you a sack in which you can put items of weight 50 kg, and you want to get back home the maximum amount of value possible. Again, for every item you can either choose it or refuse to choose it. Then what's the maximum value you can deliver or get back me at home? So for this case, for every item I have 2 options. Either I will choose it or refuse it, choose it or refuse it, choose it or refuse it, choose it or refuse it. So for example, I have a Pilot pen which is of 10 grams, but the value is very large, 1000. So maybe I can choose it, maybe I can refuse it. Next, I have a mango of 10 kgs of value 10k. I can choose it or not. I have an Apple laptop weighing 2.5 kgs of 2 lakhs. I can choose it or refuse it. I have a GF of 46 kgs, which is amount, I'll not say, which is of the amount I don't know, because so now you have to put these items in your sack. I don't know what you will put in, but I will put laptop, mango and pen. But what you put in at every situation, you can memorize that, and thus DP comes in picture. Some other real life use cases is actually by buying or selling your stocks. So there's a very famous problem, buy or sell stocks, in which you can buy and sell multiple stocks, and from that you learn to the maximum profit possible. Thus it is used by traders and stock market also. Next is your robot room cleaning. For example, you have a robot cleaner. It internally uses dynamic programming to know that which path he has traveled and which cells he has covered and what not to cover next. DP is also used in your DNA sequence. Whenever your friend says "मैं तेरा बाप हूँ," just ask him to apply DP in your and his DNA sequence and to know if he is your father. Because we know that DNA sequence is very big. It can go exponential and it actually goes exponential, but you can actually memorize many states in that. And not only this, but it is also used in your transportation problems from source to destination. If I want to go and transport it, then also I can apply DP. Last but not least is actually your graph. So it is used for tracking your relationships and finding the paths. Again, optimal paths. So when I say relationships, you can easily say social networks or basically recommendation engines. And paths, you can easily say the path finding algorithms. And as soon as the relationship comes in, for sure Insta will come in picture. So to find your mutual friends, the recommendations you get, it entirely is based on this graph data structure. Not only this, but also if you like and subscribe this channel, then YouTube will think that you like this video, and the person who have similar interest as that of you, YouTube will go and recommend this video to that person to watch this video. It is entirely based on the linking of you versus what content you like. So to show your likeness, please like it. And for sure, if you're talking about graphs, how can we forget our Google Maps? I know that the shortest path, Google Maps is itself based on the graph, and you can easily find shortest path from one node to other node because of the graph data structure. And that's how you can learn data structure algorithm in the most easiest way, by linking everything to their real life applications. Now go and forth, bye.